So in lesson 11, we are dividing expressions by a single term, which is just a fancy word for saying that algebra is about to get what I call even more interesting. I really love algebra just as a method of, I find it kind of relaxing in that you just follow the process, you cancel out the factors, you get to cross things out, move things around. I think it's very relaxing to write out that process. And as the expressions get a little bit bigger, it's even more important to write out the process that we're going through to get these numbers. And so when they get bigger, it just gives us a chance to look at the numbers and analyze them, use that side of our brain that's logical, rational, orderly, put things in order. That's how I see algebra. So hopefully you're getting kind of an idea that maybe it can feel like that. If not, you're absolutely allowed to hate algebra still. I will still respect that. But just in case you like it, I really love this lesson. Alright, so let's look at this problem. We're dealing with 6x squared y squared plus, that's plus sign, 8x y squared plus 14x squared y divided by 2x y. Now, as you can see, what we have here is a problem that merges several things. It merges multiple terms. Remember from previous lessons, this is a term, this is a term, this is a term. It merges an expression of addition of terms. Remember, an expression is just several terms that are either added or subtracted together, so this whole thing is the expression. And it's merging exponents and multiplication and division of exponents, all of those things we just covered. It's merging all into one thing, and you can start to see where the giant hole is for this algebraic. All of these parts we've been learning get put together now. So how do we solve this question? Now, solving this question isn't exactly what we want to do because we don't have the variables. We don't know what x is, we don't know what y is. And until we know what x and y is, we can't actually solve this for any valuable number. It's just waiting to be ready so that when we do our experiment, or we get in our data, or we see our analytics from our YouTube video, or whatever it is that our x's and y's are, we can plug those into our equation and figure out what our answer is. So this expression is just waiting to tell us useful information as soon as we have the variables. But in the meantime, this expression is huge and a little bit complicated looking and a little bit scary, and we want to see if we can make it simpler. So instead of actually solving this equation, what we're going to say we're going to do is simplify the equation. We want to make it in its simplest form as possible so that it's actually useful to us when we finally get those variables in. Alright, so how are we going to simplify this equation? Well, the answer is that we want to solve each term in the expression separately. So what we're doing is we're dividing all of these by this. So we're going to take each one separately. Let's start with the 6x squared y squared one. We'll do 6x squared y squared divided by 2xy. And then if we were to rewrite this showing exactly what we were going to do, we would then add that to 8xy squared divided by 2xy, and add that to 14x squared y divided by 2xy. And if we solve all of those individually, we can then put them back together or add them up, whatever it takes, to get a much simpler equation. Alright, so let's look at this. I'm going to move our board just up a little bit so that we have room to work. Alright, so 6x squared y squared divided by 2xy. We know how to do this. You know how to do this. It's pretty simple. 6 divided by 2 is, you got it, 3. So 3 on the top. I'm going to draw in our bottom. Alright, x squared divided by x. Well, 2 minus 1 is 1x on top. And y squared divided by y. Well, 2 minus 1 is 1, so we have 1y on top. And so in this case, our bottom equation is just 1, like that. 3xy divided by 1 is our first term in this new simplified expression. We're going to add that to, let's solve this one, 8xy squared divided by 2xy. Once again, let's start with the numbers. 8 divided by 2, you got it, 4. It's going to go on top of our equation. And I'm writing this one, sorry, let me explain this one really quick. This one is because when we divide the factors. So let me write out these factors real quick. We have 2 times 3 divided by 2 times 1, right? So 2 divided by 2 is 1. We're left with 3 divided by 1. 3 divided by 1. That's where I'm getting this 1 from on the bottom right here. And sometimes it's useful to remember that this could still be written as this fraction just in case anything else shows up with a bottom denominator. So that's why I have that one. Just wanted to explain that in case you were confused. All right, so moving on. So we have 4 in this case divided by 1, once again because of that leftover 1 from the factoring. And then we have x divided by x. When we have x and x, that just divides by 1 and cancels itself out. No more x's. And y squared divided by y, well, as we did this one, it's just going to be y. So in that case, we have 4y. That takes care of that equation. So let's move on to this one. All right, numbers first. 14 divided by 2. Well, we know 2 goes into 14 7 times, so 7 on the top, divided by 1 on the bottom. And then we have x squared divided by x. Well, we know 2 minus 1 is 1, so we have 1x on top. And then y divided by y, those cancel each other out, and we're left with 7xy. All right, so this is what we've got. All of this simplifies down into 3xy. I'm going to drop these bottom ones now. Since everything has 1 on the bottom, they aren't useful anymore. They're just redundant, so I'm going to drop them. And we're just going to have 3xy plus 4y plus 7xy. Now, if you're looking at this, you can see something. One way we could simplify this further. Remember, we can add and subtract any terms that are exactly alike in their variables. Similar to how we add fractions that our bottom denominators are the same, so 1/4 plus 2/4, we could add that together. We can add anything that has exactly the same variables together. So which one of these three terms, have exactly the same variables? You're right, 3xy and 7xy. Those are exactly the same, so we can add them together and simplify this equation even further. So 3 plus 7 is 10xy, and that leaves us with a lonely 4y. And that is the answer, or the simplified version, of this equation. And as you can tell, when we finally do get our variables in, I want to be plugging my numbers into this equation way more than I want to plug them into this equation, because this just looks terrifyingly nasty, but this I think I could actually handle. So, I don't know about you, but I think this way is much better. Alright, let's do another problem. Erase all of that. And here, let's do this one. 4x squared plus 8xy squared minus 24y squared. They're getting fancy. They're giving us minuses in this one. Divided by 4x to the 4th. Alright, now you can pause the video and solve this one on your own, or just solve it along with me this time around. Here we go. Remember, when we're solving and simplifying questions like this, we want to deal with each term on the top separately. So let's do 4x squared divided by 4x to the 4th plus 8x y squared divided by 4x to the 4th minus 24y squared divided by 4x to the 4th. All right. I'm going to move this down so that we can have a little more room to work with. I don't really want to cut off everything off the top. There we go. All right, let's start with the first one. 4 divided by 4. Well, we know that's 1. I'm going to write it as 1 over 1, just like I did before. Keep that bottom denominator until I know I don't need it anymore. So 1 divided by 1. And then x squared divided by x to the 4th. In this case, our larger exponent is on the bottom, so we're going to do 4 minus 2. And 4 minus 2 is 2. So on the bottom we have x squared. And on the top we just have another 1. Alright. Then let's move on to the next term. 8 divided by 4. is 2 on the top. Once again, I'm keeping that bottom denominator of 1 just in case it's useful. All right, and then we're looking at x divided by x to the 4th. And so we know, once again, the big one's on the bottom, so 4 minus 1 is 3. We're going to have x cubed on the bottom. And on the top, we have y squared, but there's no y on the bottom, so we can't do anything with this y squared. It just has to come back down here and live out its lonesome existence. Y squared right there. All right, then we have this last one. We're going to do subtracting 24 divided by 4, which is 6 over 1, just in case that denominator is helpful. And we have y squared on top and x to the 4th on the bottom. We have no common variables here, so our answer is just going to be y squared on the top and x to the 4th on the bottom. Alright, what does that equal? Is there any way we can simplify this any further? Well, in this case, I'm looking through, and we don't have any common denominators. We have x to the 4th, x to the 3rd, x squared. None of those are common. We can't add and subtract those together. Those fractions are kind of nasty. So the best that we can do is rewrite this to take out all of my extra denominator numbers. That didn't end up being very helpful, but I just wanted to keep them in case. So in this case, we just have, without this denominator, we just have 1 over x squared plus 2y squared over, we don't need this one anymore, we can just write x cubed. We know there's only one x cubed there. And then we're going to subtract that from, once again, we don't need that 1 anymore, we can just do 6y squared x to the 4th. And you might be looking at this and being like, well, that doesn't look like a simplified problem at all. That looks absolutely disgustingly nasty. And you're right in a lot of ways. I mean, it's not amazing, but I think it's better than that. So this is going to be our final simplified answer for that problem. And that's as good as we can get it. We can't get it any more simple than that. We don't have any more common terms. We don't have any common denominators. We don't have any more common variables. So we just have to leave it at that. All right, let me see if there's anything else important to learn from this lesson, or if I can send you loose on your homework. Okay, there is one other thing I guess it would be important to note. So we're going to do the similar problem again. I'm going to move it up though. Let's see. Let's go up here. So same problem, but there is one other way we could have solved this to write it. Because when we got to the end of this answer, we're like, well, that doesn't look any less nasty, really, you know? So another way we could have done this is, instead of going through and dividing each term separately and dividing as much of the variable out as we could, ending us with this x squared on the bottom, x cubed on the bottom, x to the 4th on the bottom, another thing we could do is just look at this problem, and are there any common factors in every single one of these terms that we could divide out? And now remember, it has to be common in every single one of them for us to do it to any of them. We have to do the same thing to all of our terms, you know? We can't just do one to one of them and leave the rest alone. We have to do the same thing to every single term. So you have to find a factor that is consistent through every single one of these terms, and then we could deal with that. Now looking at these, are there any common x's? Well, we could look and be like, well, this has an x, and this has an x, and this has an x, but then you look at this one and it doesn't have an x, so we can't divide x out of that very easily. We could look at y's and be like, well, this one has a y, and this one has a y, but these two don't have y's, so we can't divide y out. So that's not going to work very well. Oh, I kind of just deleted my y tails. There we go. But there is one thing that does have a common thing. 4. This has a 4. This one has a 4, if we think of it in its factors, 2 times 4. This one has a 4, if we think of it in its factors, 6 times 4. And this one has a 4. So we could take a 4 out of this. So let's divide 4 out of all of these terms. And I could write it out individually if I wanted to, but most likely that's not the most helpful way to do it. It would just get confusing. So let's just go through and make sure we do the same thing to every single one of these. and then rewrite our problem. So 4 divided by 4 is 1. So that means this term is going to be x squared. The 4 is gone. And 1 doesn't really matter. I guess we could put the 1 in there if we wanted to. That's a very terrible one. All right, 1x squared. Now we're going to do the next term. 8 divided by 4. Well, that 4 cancels out along with that 4, so we have 2. We're going to put our 2 and then xy squared. Lovely. And then we're going to do our last term. So 6 times 4, or 24 divided by 4, is going to leave us with, that 4 cancels out and divides out, and that leaves us with 6. And then y squared, we couldn't do anything with the y squared, so he stays there. And so then on our bottom, we've divided out this 4, and so all we're left with is x to the 4th. And so this would be another appropriate way to solve this problem. Instead of going through and trying to simplify it down, every single term divided by its maximum possible things we could divide it by, but that leaves us with, 3 distinct terms at the end that we can't add together because they don't have common denominators. Well, in this case up here, we've just taken out only the things that are common among every single term. In this case, that's just the number 4. And that leaves us with the same denominator on the bottom, this lovely x to the 4th, so we can write it all as still one expression, and sometimes we like that better. It looks prettier, it kind of feels a little calmer than this answer does. But either of these answers would be correct, and if we were to put in our numbers for x and y and solve the problem, both of these answers would give us the same answer in the end. So we could do it either way. Hopefully that makes sense. You will have a chance to practice this